Hello people, I am Michael James B. Ambrosio of BSECE 3A, and today I'm going to discuss the three terms in the uploaded terms and definitions in related to fiber optics. So these three are based from my first name, middle name, and last name initial letters. So I choose MEMS for M, and band radius for B, and AR coding for A. So let's get started. So first in line, we have here the MEMS, or the microelectromechanical system. So what is a microelectromechanical system? So microelectromechanical system is a miniature machine with both electrical and mechanical components. MEMS technology can fabricate capacitors, inductors, and mechanical elements such as gears, springs, beams, and etc. Also, it can be a tiny moving mirrors fabricated from a semiconductor materials. Here we have the components of MEMS. So first, the microelectronics. So this one serves as the brain. So microelectronics receives, processes, and make decisions. Second, the microsensors. So microsensors constantly gather data from the environment. Third is the microactuators. So microactuators act as a trigger to activate external device. Lastly, the microstructures. It is extremely small structures built on the surface of the chips. So here in your screen, we have here an example of MEMS, which is this one is called the carbon monoxide or hydrogen gas sensor. So generally, MEMS are devices within range of 20 to 20 micrometers to 1 millimeter. So this one, the carbon monoxide or hydrogen gas sensor, is suitable for the detection of carbon monoxide or hydrogen leaks in electronics products such as mobile phones. Next, the band radius. So what is band radius? Band radius is the minimum radius that a fiber optic cable can be bent without loss of light or impairment. It is the smallest radius an optical fiber or fiber cable can bend before excessive attenuation or breakage occurs. The band radius is the radius varies with different cable designs but follows a general rule that it can be no less than 15 times the cable diameter. So, bend radius, excessive bending of a fiber cable could cause both macrobends and microbends. So, macrobends is the loss of light, while the microbends is the glass impairment. But later on, bend-sensitive fibers have been developed that dramatically reduce the bend radius and allow for non-linear deployment of fiber cables. Next is the AR coating or the anti-reflection coating. What is anti-reflection coating? A thin dielectric or metallic film applied to an optical surface to reduce its reflectance and thereby increase its transmittance. It is a type of optical coating applied to the surface of lenses and other optical elements to reduce reflection. In typical imaging systems, AR coating improves the efficiency since light is lost due to reflection. So in reflectance, light passes through a transparent materials like this one, the lenses, and some of the lights will be reflected off of the front surface of the lens, but the majority of it will be transmitted through. But through AR coating, some light can be manipulated to reflect it back. So the coating works by creating another transparent layer over the lenses, and instead of one reflection at the front surface, so now they will have two reflected surface in the lenses. So the two major applications of the AR coating is for the corrective lenses and the camera lens elements. So for the corrective lenses, it decreases the reflection and enhances the cosmetic appearance of the lenses. While for the camera, for the photolithography, so the anti-reflective coatings are often used in microelectronic photolithography to help reduce image distortions associated with reflection of the surface of the substrate. Therefore, after the photoresist, it helps reduce standing waves, thin film interference, and spectacular reflections, resulting to a great image. So, that would be all for the definition of terms given in our Module 7. Thank you again.